Okay, selection of acid-base indicator in titration. The correct indicator in an acid-base titration is selected based on the pH of at the equivalent point of the titration. An indicator must have its pH transition color change, that is the pH transition range, within the steep-rise vertical portion of the titration curve. Acid-base titration is accompanied by change in hydrogen ion concentration or change in pH value of the solution. When base is added into acid or vice versa, depending upon the nature of the acid-base titration, the end point occurs at a particular narrow pH range. Indicators also have their particular color change in pH range. While choosing indicators in acid-base titration, following points to be noted. The action of indicator should be quick. That indicator should be chosen which would minimize the titration error. The color changing pH range of the indicator should coincide with endpoint inflection point pH range. When base is added into acid or vice versa, there is change in pH value of solution. A graph of pH of solution versus volume of alkali added or base added can be plotted, which is called titration curve. Titration curve is very useful for the choice of indicator in acid-base titration. The titration curve for different types of acid-base reactions are given below. pH of solution, strong acid, strong base, weak acid with base. The pH 3 to 11, case of strong acid, strong base, and weak acid with base 6 to 8. Titration of strong acid, strong base, when the strong base is added from burette into conical flask containing strong acid, hydrochloric acid, then initially there is a smooth increase in pH value. This is shown by the curve AB in the figure. Okay, the titration of strong acid and strong base. When strong base is added from the burette into conical glass, containing the strong acid. Then initially there is a smooth increase in pH value that is shown by the curve AB in figure. On successive addition of base into the acid, sudden rise in the pH value of the solution takes place. In point of course within this inflection, this is shown by the curve B. On further addition of base, the pH value solution increases smoothly shown by the curve EF. In such type of titration, endpoint occurs within the pH range of 3 to 11. Any indicator capable of changing its color within this pH range in a choice of this titration. We know the color change in pH range of methyl orange is 3.2 to 4.4, and that of the phenolphthalein is 8 to 10. So either methyl orange or phenolphthalein is used as indicator. Titration of strong acid with base. When the weak base ammonium hydroxide is added from the burette into conical flask containing the strong acid sulfuric acid, then the nature of titration curve is shown in figure. On weak base into strong acid, the pH of the solution initially increases smoothly as shown by the curve AB. The smooth in pH value is due to gradual neutralization of hydride ions of acid by base. A steep rise of the curve is observed, the pH range of 3 to 8. In the above example, when ammonium hydroxide reacts with a strong acid, sulfuric acid, ammonium sulfate is formed as a result of neutralization. The ammonium sulfate ionizes completely and free ammonium combines with hydroxide ions of solution. So in point occurs below pH 7. The sharp change in the pH value occurs within the pH 3 to 8. Hence, any indicator capable of changing its color in the acidic medium, the choice for this type of acid-base titration, since color changing pH range of methyl orange is 3.2 to 4.4, methyl orange can be used as indicator in the titration of strong acid and weak base. Titration of weak acid strong base, the titration curve for the weak acid and strong base is shown in figure. When the weak acid is taken in the conical flask, it will have the obviously higher pH value. On adding the strong base from burette, the acid is gradually neutralized and pH value goes on increasing. When ethanoic acid reacts with the sodium hydroxide, sodium ethanoate and water is produced. If we consider a titration of weak acid in a strong base, then salt, sodium ethanoate and its salt with strong base acts as acid buffer solution and resist the change in pH to some extent. The pH of such solution is given by the Henderson-Hasselbalch equation, pH equal to pK plus log salt over acid. Weak acid versus weak base titration. The titration curve for this type of titration is shown as shown in figure. The nature of titration curve depends upon the ionization constant of weak acid and weak base, or pKa or pKb value. The endpoint occurs within the narrow pH range and does not show sharp change in the pH during the titration. In this case, endpoint occurs within the pH range 6 to 8, so there is no appropriate indicator for this type of acid-base titration. The equivalence point of this titration is determined by conductometric titration or potentiometric titration. Okay, it's all about selection of indicator. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That's now bye bye. See you.